Hey 779, it's me, Warrant Officer First Class Kermack. Welcome to our channel. Today we're going to be talking a little bit about model rocketry. So later on in this video we'll be launching a water bottle rocket and a small engine rocket. We won't be showing you how to make a small engine rocket, but if you want to learn, there's videos online, and then the instructions are of course in the package. But for the water bottle rocket, basically what you'll need to do is just have a water bottle of some sort. Like I have a pop bottle here. This is an old rocket. So I won't be launching this one, but I will be launching a different one. So all you really need is like a water bottle, like as long as it has this thing at the end, so it can't be like a can or anything like that. It can be as big as you want, as small as you want, as long as it has this at the bottom. So what you'll need is to have some form of cone at the top to allow it to fly better, and of course you need to have your fins. So those are the two things you need to keep in mind that you need to have. So you can basically use paper for both. Maybe use cardboard for the fins if you have that as an option, but I do recommend paper or for the cone. So that's basically what you'd need just to make a simple little bottle rocket. And then of course you can design it how you'd like, up to you. So for this part of the video, we're going to be talking a little bit about the physics involved with model rockets. So now we're going to talk about the Newton's 3 laws of motion. So first we're going to talk about the first law, the law of inertia. So this law states that an object in motion stays in motion, and an object at rest stays at rest unless acted upon by an unbalanced force. So what this means is, say that I have my water bottle here, and I have, say that we're in space right now. You can see behind me, we're in space. So and I throw the water bottle. So an object in motion stays in motion. There'll be no unbalanced force that goes against it. So like an unbalanced force like gravity or like a rock or something will hit it. So this will just keep going forever until it hits something. And then if it's stationary, or like so right now, as long as my hand stays stable, it's not in motion. It remains at rest since there's no objects. There's no unbalanced force acting on it because my hand force is stopping gravity. So, but let's say that I threw the water bottle up, so it'll be in motion, but then the unbalanced force acts upon it, so gravity in this case, and then the water bottle would go back down and hit the ground, and then it would stop there. So that would be the unbalanced force stopping an object in motion. So if I go like that, then that's an example of Newton's first law. So for a rocket, in this case, I'll grab my rocket here. So for this one, as the rocket travels upwards, it'll be same as the water bottle. The unbalanced force of gravity and air resistance will actually act on it too. Air resistance will act on it, gravity will act on it. So those are the unbalanced force acting on the object in motion. So then it'll eventually stop, and then it will go back down and then hit the ground. So that's Newton's first law. So in my opinion, that's one of the harder ones. So we're going to luckily be able to move on to one that I find pretty easy. So this is Newton's second law. This is the math one. So this one states that force is directly proportional to mass and acceleration. So the formula for this would be F equals mass times acceleration. Let's see if you can. So there's the formula. Hopefully you can see that. Okay, actually I'm going to move this a little bit closer so you'll be able to see it a little better. So force equals mass times acceleration. Move this out of the way. So force equals mass times acceleration. There's also a way to do it so that it's a vector. So what a vector is basically just adding a direction to the magnitude. So let's say, so it would be like going west, east, south, south, north, left, right. That's added a direction to the magnitude. So, but for today, we're just going to keep it simple. We're not going to worry about vectors. So we're just going to use F equals mass times acceleration. So mass is pretty simple. It's just the mass in kilograms. Simple as that. For acceleration, I'll explain a little bit what acceleration is. So let's say we have my marker here that's moving at a constant speed. So it's moving at a constant velocity. But if it starts off slow and then I speed it up, then that's accelerating. So how to find acceleration? This is the formula for that. So it would be the change in velocity. So that would also be a vector there, but we won't worry about it. The change in time. So that what this means is v2, so the final velocity, minus the initial velocity, divided by t2 minus t1, so the final time minus the initial time. So we'll go into an example of this. So let's say that we have the final speed is 5, so our unit is meters per second for velocity, minus 1 meter per second. So then our time for the unit for time is seconds. So let's say that we have 4 seconds minus 2 seconds. So at the 2 second mark, it's going 1 meter per second, and then at the 4 second mark, the final speed will be 5 meters per second. So then this would be 4 divided by, it would be 4 meters per second divided by 2 seconds, and then our final answer would be equal to 2 meters per second squared. And that's our unit for acceleration. So I'm just going to erase this. So we keep that in mind. So our acceleration is 2 meters per second squared. And let's say that our mass is also going to be 2 kilograms. So we have force equals 2 kilograms times, what we have, it was 2 meters per second squared. So kilograms times meters per second squared is equal to a unit called newtons, named after Isaac Newton, guy who found this law. So 4 newtons is our answer. So it's 2 times 2 is 4, and then kilograms times meters per second squared is newtons. So there is our final answer, and that would be the same if we had a 2 kilogram rocket that's accelerating at 2 meters per second squared. So that's how this one fits in to the formula. You'll be able to calculate the force that it's applying and using its mass and acceleration. So finally, one of the easier ones, that's the only one I need to use the board for, so I'm going to move this back. This one's an easy one in my opinion. Newton's third law of motion. This one is every action has an equal and opposite reaction, meaning that so if I apply a force to the wall, I'm applying an action. So if I push against the wall, I'm applying a force towards the wall, and then the force is applied back at me with the same magnitude from the wall in the opposite direction. So I'm applying an action, and then it's going to so every action has an equal and opposite reaction. So the reaction is it pushing back on me when I do that, and in the opposite direction. So for a rocket, it would be, so the fuel coming out of the bottom, for our example, would be something like air pressure. So as it's pushing down, the ground or the air is pushing back up at the rocket, and so as the rocket pushes out, it pushes the same force back in the opposite direction, which allows the rocket to go up. So that's about it for the physics portion of this video. So we're going to go and cut to launching this and the small engine rocket. Hey 779, it's me again. So now we're going to be launching the water bottle rocket right here. But first we're going to show you how everything works. So here is the water bottle rocket launcher. So it starts off by you're filling up your water bottle to about 10% with water, just so that there's something that's blocking the air compression here when you put it in here. So that's how that works. And then from here, what you need to do is you need to make sure that this valve is closed here, and then you pump here until it gets to a good amount of PSI. I usually go for 100 or 120. And then as soon as you get to that amount, it runs out quickly. So as soon as you see 120, then you got to turn this, and then it will launch the water bottle rocket. So I'm here at the local park with my dad. So and we're following social distancing regulations. So make sure that you're doing the same if you decide to try this. So as you can see, the water bottle rocket went about 2 stories high. So it does take a little bit of energy to pump that, not too much that we can't handle though. So this is the one that you can do at home. It's the easy one. It's pretty fun to do. But the one that you're about to see will be the small engine rockets launch, which goes about 80 meters in the air. And that one has an engine. So that one's pretty fun. If you do want to do this, make sure that you're following social distance guidelines and make sure that you're being safe. Other than that, if you follow those, you'll have a pretty fun time. So we'll see you right now. Hey 779, it's me again. Now we're going to be doing our small engine rocket. So here's the small engine rocket. As you can see, we have the engine already loaded. We're using A8-3 model rocket engines. And it has it's all ready to go. So I'll show you guys what we have to work with here. So we have all our first aid supplies in the garbage can on our table here. So there's the first aid supplies and the fire extinguisher in case need be, because we are dealing with engines here. So I'll show you guys how this works basically. So when the rocket lifts off, it'll begin with the liftoff, and then it will begin to accelerate. It will begin its climbing phase, and then it'll be the apogee and ejection. So what that means is that when it gets to a certain height, this cap will pop off, and the parachute will deploy, meaning that we can reuse the rocket again. So this rocket will go up about a decent height. It'll go to about 85 meters in the air. So we need to put in the recovery wadding first into this in order so that the engine does not burn the parachute. We have some extra engines here if need be. So over here is the launcher, or the control switch. And so this will not work without the key, so make sure that you have the key in when you're going to launch it. But since we're not launching it, we got to keep the key out, and then you press the launch button when that is ready. So here's the wire. So this part here is going to attach to the engine clips, and the important part here is to remember, make sure that these aren't touching each other like that, or else I believe it won't work. So those two clips go on to these two clips right here once we attach the engine. So I'm going to put in the recovery wadding now, and then we'll get back to you in a second. Okay, so we've inserted the recovery wadding into the rocket now. That being said, make sure that you do this just at your local park, or somewhere where you have not a lot of people, or things that can crash into or the rocket can crash into. Also make sure that you have an adult near you and make sure that you're following social distancing guidelines. We have my father, an adult over there, so we're good for here. So if you decide to get into model rocketry yourself, make sure that you do the same. So we'll put this on here now. So we're getting ready to launch. So we have our alligator clips here. We'll attach them. Just got to make sure that they are not touching. There we go. So they're not touching. So now we're ready to launch. So we'll see you in a second. Alright, so we're going to put the key in here. As soon as we see the light, there it is, that we're ready to go. So we're going to do a countdown now. We want to record the rocket there. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Come on, parachute. Yes! Alright. There we go. Parachute deployed.
I didn't know where it was.
So watch it there, and it's gonna come down. Don't land in the tree, and we are good. Alright. There you go. Okay guys, we're gonna do a second launch now. As you can see from the first one, it made a mark right there. So this one should also, but that's no problem because it's meant to get damaged in that way. So we're gonna do another countdown. We're gonna see if we can get a better angle of the shot this time. So I'm gonna do a countdown. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh, it's right on top of us. I don't know if you can see it. Oh, there it is, parachute deployed. It's landing right over there. Okay guys, we're going to do one for the third launch, the final launch of the day. So we've had 3 successful ones, so hopefully this one will be pretty successful too. We'll do another countdown. We'll see how it goes. So there's that. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh, there we go. Whoa, it's falling quick. It's gonna land over here. There we go. Alright, so we're back now. One thing I forgot to say in that portion of the video is make sure that you're pointing up at the rocket in the air, so that way you can see exactly where the rocket is at all times, and if it appears to be landing, it's going to be landing on someone, then you'll be able to shout and say heads up that the rocket's going to land on you. So that being said, in this video you learned about Newton's 3 laws and how they apply to model rocketry. So an object in motion stays in motion, and an object at rest stays at rest unless acted upon by an unbalanced force. That's the first one. The second one is F equals ma. And then the third one is every action has an equal and opposite reaction. So hopefully you learned something from this video. Hopefully you enjoyed seeing me launch the rockets. If you want to try this yourself, make sure that you're doing it safely and you're following social distancing guidelines while you're doing it. That being said, make sure that you're subscribed to this YouTube channel so that you can catch not only my videos but the other flight sergeants' videos as well. So that being said, keep an eye out for podcasts and other videos, and my name is Warrant Officer First Class Kermack, and I will see you next time.